Okay, we're going to talk about soil glue, which is in section 5 of your educator's guide. And the goal is to show students or demonstrate that less disturbed soils contain more soil glue and hold together better or have better aggregate stability. Demonstrate why it's important to protect soils from disturbance such as tillage, and then provide examples where soils must be disturbed with further investigation actions that can be taken to protect them. So to demonstrate this and demonstrate to your students that you could have them bring soils from their own farms, and it's important that you go ahead and let the soil air dry. So you don't want to run this test when you have moisture already. So what we want to do is get some different management systems to run the experiment. In this example, I'm going to show 3 different soils that have been that managed differently. And so we use the little cups that were provided in your soil bucket. And there's little screens, and we fill each of these 3 cups up to where it just comes above where the clod will sit. Okay. So from here, what we want to do is have our different soil management systems. In this case, I gathered these soils from northeast Nebraska, and this is a Crofton Silt loam, and this has been tilled. Okay. So with this test, we're going to be putting it in here, and we're going to be filling all the pore spaces in these clods with water, and eventually under internal pressure we're going to see if they will break apart or hold together. Okay, so hence the term aggregate stability. So I want to go ahead and get each of these so we can fill up all the pore spaces. Now what I want to show, and I'll pick this up so you can see a little better. This is the tilled Crofton Silt loam, and you notice how it's breaking into small particles, falling apart under the internal pressure. And if I touch it, it really breaks apart quickly. All that sediment stays in suspension. Okay, here is a little better soil. That's a Judson soil that's been managed again under no-till. You notice when I touch it, etc., it doesn't break apart. So it's got 2 things going for it. One, it's got high organic matter. One, it's been no-tilled, so it's not going to break apart very easily. And the importance of this for water quality is it's going to provide better infiltration. It's going to provide better hold the nutrients, hold your nitrogen, hold your other nutrients better for your crop production. And then here is that same Crofton soil that we showed you first, except this has been under no-till for about 15 years. And you notice that it does break apart some, but when it breaks apart, I touch it there, you can see that the soil that does go through the water column there was more aggregated and holds together. So the importance of that is again for our soil structure to stay intact, so that we can have a good active soil microbiology system going there, and that we have good available water capacity, good available nutrients are held and exchanged well with your crop.